Hello, good evening. Let's delve into a problem from physics. It is beneficial for both class 9 and 11. So let's check it out. Suppose the question is an object is raised from P to Q through three different cases. Like suppose this is the base, the ground. Suppose here is the object. The object is at the point P, is raised to the point Q like this through height h. This is case 1. In another situation, the object is raised like this from P to Q. The height remains the same. Okay, the height through which the object has been raised from P to Q remains the same, but through a different path. Okay, path is like this, kind of like this. So that's case 2. Okay, in another case, the object has been raised like this, P to Q, same height. Okay, but through another different path. My question is, will the potential energy remain the same or different in all the 3 cases? On this case 3. Okay, so it's a question from the chapter work, power, energy. This chapter is there in both class 9 and 11. So let's talk about potential energy. Now potential energy, which we call potential energy, which we call work done against gravity. Okay, and it has a formula U is equal to m into g into h, which means the potential energy depends on the height to which the object has been raised. So U varies directly as the height. Okay, so in all the 3 cases, let's check. In the first case, the body has been raised from P to Q to the height h. In the second case, the path is different. Okay, the path is different, but the object has been raised to the same height. And in the third case, the path is also different, but the object has been raised to the same height. So what we say is that the potential energy depends on the difference in vertical heights. That means the final and the initial position. So the final position is what? So in case 1, I can say the final position is Q, SQ minus SP. In case 2, the final position is SQ and the initial position is SP. In case 3, the final position is SQ and the initial position is also SP. So in all the 3 cases, the difference in heights, the difference in positions are the same. So we can say that H. So we can say that the potential energy in all the three cases are the same. So which is nothing but mgh. So your answer will be the potential energy remains the same in all the three cases. That's nothing but a conceptual question. Yeah. Okay, now let's move on to the next question. Question 2. When a player hits a football into the ground, it moves into a parabolic path and then hits the ground. What will be the work done? What will be the work done by the force of gravity on the football? Okay, the question here is about work done due to gravity. So let's see the case, like let's draw the case scenario. So that's the ground. Okay, here's the football. Okay, when you hit the football, it goes like this. And then it hits the ground. Okay, and never mind my drawing, it's just rough. Like this path, we call this as parabolic path. What happens here, when we start kicking here, so here is the initial position h1, and when it got hit by the player, it moves onto the ground and the final position is h2. So how can we say about the difference in heights? So h will be h2 minus h1, which is final position h2 minus initial position h1. So both are same because both are at the same level. So you can say, because h1 is equal to h2, since both are the same level, so you can say h2 minus h2, which is nothing but 0. And now we know that work done by the force of gravity, is nothing but mgh, mg into 0, which is 0. So the work done by the force of gravity on the football is nothing but 0. So this is the case. Even though much amount of work has been done, but work done by the force of gravity on the football will be 0 because it depends on the difference in the final and the initial positions of the object, the way in which it has been kicked. Okay, now let's move on to the third problem. A man weighing 60 kg is ascending a ladder 10 meter long, making an angle 30 degree with a horizontal. Calculate the work done by him against gravity. Now let's just make up the situation now. Okay, first we need to make up the situation. So it's the ground level where everything is situated. Okay, this is the wall. Okay, now this is a ladder. Okay, this is the ground level. This is the wall, and this is the ladder. Okay, suppose here is the man. just ignore the diagram in the man because it's not perfect and I'm not good at drawing so much. Okay, it's my name. Now suppose the man is ascending. Okay, making an angle 30 degree with the horizontal. The ladder is making an angle 30 degree with the horizontal. So this is the horizontal line, which is the ground level. Horizontal, ground level. The ladder is making 30 degree angle. Okay, now let's find out. Calculate the work done by him against gravity. So what's the formula? So let's just write given data here. Given mass is 60 kg. Okay, now ladder is given. Suppose let us take the length of the ladder as d. Let this be d. Okay, let this be d. D is given what? As 10 meter long. Therefore work done by him against gravity. We know the formula. W is equal to mgh. What is h here? Don't get confused with h and d, because d is the length of the ladder and h is the vertical height through which the man ascends from the initial position to the final position, like this. Okay, this is the height. I mean from the initial position, that is 1, to the final position 2. We need the vertical height. This is the vertical height, h. Got it? We need h anyhow. So for that we have to use the concept of trigonometry here. So let's take this triangle as A, B, C. Okay, so for height, I mean this side is equal to this side. Since it's a rectangle, so we can say that so let's find out this from triangle ABC. What is cos theta? Cos theta is nothing but base by perpendicular. Okay, what is base? BC by perpendicular, which is AC. Cos theta. This is the theta here. That's theta, not 30 degree. What is BC here? BC is nothing but the height. Since it's a rectangle, the breadths are equal, its height. So h. What is AC here? D. We need the value of theta now anyhow. So let's find out theta now. Since it's a triangle, we know the sum of the three angles in a triangle is 180 degree. So we can again write here 30 degree plus theta plus, now this is 90 degree perpendicular. From the diagram it seems like that. 90 degree will give you 180 degree. So theta will give you 180 degree minus 30 degree minus 90 degree, which is nothing but 60 degree. Okay, so we can write cos theta is what? 60 degree is equal to h by d. So let's find out h. H is equal to d cos 60 degree. Okay, give this as equation 1. Now let's put all the values here. What is mass? Mass is given 60 kg. G value you can take, for like assumption, you can take here as 10 meter per square second. What is the value of h? D cos 60 degree. D cos 60 degree. So 60 kg into 10 meter per square second into, what's the value of d? It's 10 here. What's the value of cos 60? It's nothing but half. From the trigonometric table, the value of cos 60 is half. So half. So now let's just find out the value here. Now this is what? Meter. Yeah, because the unit of the length is always meter. So meter. Let's write the meter thingy. 200,225. So the answer is 33,000 joule. Can write as 3 kilojoule. That's the final answer. Work done by the man against gravity is 3 kilojoule. This is how we solve a problematic sum drawing a situation. Okay.